Synapse Query Analytics is a solution to provide a complementing feature for the SQL pools inside Synapse, because SQL pools don't have the ability to store information about the object usage. For example, index usage, table usage, how many inserts for this table happened in the last period of time, how many select statement, what are the most the most frequently joined table together, so we can use this information for our designs. This information does not exist right now, so I created this solution to complement the current tools built in the product. The solution, the core component of the solution is the SQL Parser API. The SQL Parser API is built using Azure function in C# that is dependent on the Microsoft package script DOM. So Microsoft.SQL Server.transact SQL.script DOM namespace. I'm depending on this namespace to parse the SQL statements provided to Synapse and then generate analytics out of it. So to call this API, we need to have a store of the history of the queries provided to Synapse. Currently, we do support two ways. One way is from Synapse through the agnostic settings. We are storing the historical queries in a blob storage, and then we have a Spark notebook that is reading from the blob storage, communicating with the SQL Parser API, getting the analytics, and then store everything in a Spark table that is accessible by Spark and also by the serverless pool. The second way is the query store. So after configuring the query store, I built a pipeline to incrementally loading the query store queries into another table with some joining, and then from there I'm loading the data using Spark, communicating with the SQL Parser API, and then save everything in a Spark table that is accessible for Spark and also serverless pool. Quick demo about the parser, the SQL parser. So this is the published parser. We have here only one function. It's parse, and if we are providing an input like this one, where it has some content, some comments and joining between different tables, we have 4 tables here. When executing, this is the result, where we are getting the SQL command, removing all the comments, the join table, so these are the tables that we join them, the join columns out of these tables, and information is select statement is true. So this is a select statement, so we can get easily information about how many select statement for the last period of time and stuff like this, and I'll show you more demos after. And finally, I'm getting the hash of the query. The API is storing every query that we are sending to it in a storage table. So if for troubleshooting, improvements, if the data is not as expected, the result, I'm using this hash to get back to the original query and then try to troubleshoot this. The source code is already opened, it's on GitHub, and will be shared with you after the video as well. The second part is a pipeline. This pipeline is loading the data from the query store. So the data in the query store, we can access them using DMVs, and we need to have a join between different DMV to get all the information that we need. However, for Spark provider in Synapse, we cannot have a join queries. That's why I created this pipeline to make sure that I'm collecting everything, and I'm loading this incrementally, saving the last records information in a table as well, in a storage table, and storing everything in one table so I can consume it easily with Spark. Now, this is the final step in a typical loading procedure that we can execute every day or every few hours, depends on the use case. In this one, I'm getting the data that I already aggregated from different DMVs about the query store in a Spark pool. So in the Spark pool, I have some information first, like this is for the Synapse ML, and I will speak about it later. This is a parameter cell, so we can add this in the pipeline as well. The API key, so the APIs are secured and we need to have a key for it. Then loading the data, do some data engineering, and the most important part here, this is regardless of whether we are getting data from a query store or we are getting data from diagnostic logs. In both cases, at the end, after doing the loading and data engineering, we have to call the API per record in the data frame. And I'm using here the HTTP transformer in the Synapse ML, a new library that was added recently in Synapse and Spark generally. We can use Synapse ML in any Spark cluster, calling my API, providing all the information, and then getting the data in, doing some cleaning after. This is actually the last execution. It took 33 seconds, so it's fairly quick. And then the data that I'm getting, I'm doing some parsing for the JSON, make sure that that's the expected schema, and then finally saving this into a Spark table for the next step. And that will be the end of the daily pipeline that should be executed to grab all the data and save them for the real use case. Now, after the analytics is saved in our table, now the DBA, the data engineers, whoever is managing the Synapse SQL pool can have access to this information. Everything is here, and we can get more insights into the data. So for example, here I'm getting an overview about my queries, and I see that 62 of them are select queries and one is insert statement. When I go to the select statements, I can get the details where the select statement equal 1. So the details of this one, this is all in the serverless pool. There is no storage needed or even running the SQL pool when we run these queries. When we're getting the joined select, so any select statement has joins, which is the typical select statement in the data warehouses. So I can get them here. And I can get from this the frequently joined tables, where I will get what are the tables that are frequently joined together. In this case, I can get my frequently joined as I'm getting here. The first one is like a system table because I'm not using much my Synapse, but in this one I see I'm getting 6 times. I have the dimension date, the dimension city, the fact sales, and the stock item. With that, ending the demo for the Synapse Query Analytics. Thank you.